Hello. Hello, everybody. Can you hear me clearly? Okay. I am pleased to take part in this video conference. I come from the oil industry. You know, CNPC is the largest oil company in China. We take part in this afternoon's conference from our headquarters, and also some of my colleagues are interested in this talk, so they are also take part in the conference. Today, I will give a brief introduction of the carbon neutral conditions in China, and also I maybe give more focus on the CCUS EUR in oil industry, especially in CNPC. Next. My speech contains three sections. One is the role of CCUS for carbon neutral, especially in China, and they talk about CCUS technology progress in CCUS. And also we will talk about the challenges and the way forward. Please. As we know, Chinese government has announced its ambitious target for carbon reduction in 2020. That is around 2030, China will reach its carbon emission peak. And before 2040, China will achieve the carbon neutral target. Compared with Western countries, just like America, based on the data from the University. In the US, it will spend 50 years from the emission peak to the carbon neutral. But in China, we still have 30 years to go to zero. So more challenging China to get our carbon neutral. Also, we know the Kazakhstan set your target of achieving carbon neutral by 2060, right? I think it's a great target. Okay. As per carbon neutral targets or net zero emission goal, different organizations come up with this prediction in different scenarios, including conservative, intermediate, and aggressive. Within the intermediate scenario, China wants to achieve its carbon neutrality. The key conditions have to be met. By 2060, the non-fossil fuels should account for 80%, and the terminal electrification rate should reach 60 to 65%. And at that time, about 2 gigaton carbon should be captured and buried underground in China. This is the conditions for the China to get the neutral. And also for CNPC and the largest state-owned company in China, we also set up our plan for the green action plans. Besides, we should use more new energy for oil and gas production. We also set our CCUS targets by 2050. There will be 40,000 kiloton CO2 will be injected in CCUS, and also another 50,000 injected into depleted oil gas fields. And also we should prepare some saline formations to have the capacity of 40,000 kilotons. Next, please. CNPC has started CCUS research and testing more than 40 years ago. In 1965, CO2 flooding technology has been introduced into China, and the first field test implemented in Dacheng oil field. Then since 2006, CNPC accelerated CCUS R&D and conducted several CCUS-UR field tests. And by now, our company has achieved the capacity of implementation of full-scale CCUS projects. Then I will give more focus to introduce the technologies of CCUS in CNPC. And the first is CO2 capture technology. For different CO2 concentrations, capture technology differs. For concentration about 90%, we directly use compressed liquefaction method. And for consumption ranging from 60 to 90, we use low temperature rectification method. And also for the much lower concentration CO2, we use amine absorption methods, but the cost is high. Then as for the CO2 transportation, we have learned the fundamental principles of the phase behavior and properties of CO2 mixture bearing impurity substance. A 53-kilometer long CO2 pipeline has been built and operated in Zhejiang oil field and transport 500 kilotons CO2 annually in gas phase. We also are also doing some research on the circulatory transportation method. Next is CO2 flooding. To increase oil recovery factor of the oil field, in CNPC, the targeting oil fields are mainly low permeability reservoirs. To increase the cost of CO2 gathering, separation, injection, and cycling, the full portfolio equipment has been efficient strategy, including factory prefabrication and modular construction to cut cost. And the next is about the CO2 storage. There are major three mechanisms. The first is volume replacement to the initial oil and the CO2 being kept in the gas phase. The second is dissolution retention in the underground water areas. And the third is mineralization reaction. Based on the mechanism, we can calculate how much CO2 can be in different parts and calculate the to date in CNPC, we have implemented 42 CO2 projects. Totally, there are 4 million tons CO2 has been injected, and the expected incremental oil recovery will reach more than 50%, and the storage rate is more than 50% CO2 oil displacement rate, which means if we inject 3 tons CO2, we can extract 1 ton hydrocarbon oils. Also, we're still facing some challenges for the CCUS. We just listed about the CCUS challenges here. And from the whole chain, the industry chain for the CCUS, we still have some challenges or some works we need forward. Yes, on the way forward, there are still some technical problems need to be mitigated. to capture lower concentration CO2 emissions, the cost must more than accepted. We need low-cost technologies to refit the existing power and industry plants. Long-distance pipeline and supercritical phase transportation are favorable to support large-scale CO2 transportation. Then how to promote sweep efficiency in CO2 flooding, particularly in immiscible conditions, just like in the CNPC, is a critical problem. And also the safety problem involving leaking monitoring or surveillance, and also some of the policies of the government to subsidy CCUS implementation. And in the end, some conclusions I talked about above. I don't want to repeat it again. Just one thing I want to emphasize is the CNPC has established extensive cooperation with Kazakhstan, and we are looking forward to expanding the areas of cooperation between both of us, including on the CCS and the CCUS projects. And that's all. Thanks for.
Thank you very much.